Good afternoon, everybody. I hope you can hear me well. Okay, if anything is wrong about internet connection, let me know. I will change my connection to, anyway, let me just do it now. I think it's better. Okay. Okay. So as you may actually know, we are going a bit fast. And after all, actually, these topics are really related to each other. If you understand the basic idea, I hope by just practicing the questions, you can improve your problem solving skill a lot. And I'm thinking maybe I will share some videos from each exercises. I'm going to solve a few questions, and that means that those questions will be really similar to the questions that I am going to ask in the quizzes or in the final exam. Okay, and after all, now we have a lot of videos uh, related to calculus class on YouTube, and also we have solution manual rates. All the questions are solved step by step in a clear way. The only thing you have to do is just you need to spend some time, sit and practice the questions. If you don't understand, have a look at the solution manual and try to understand. If you still don't understand, you can just ask your friends, or you can just visit my office, or just take an appointment. Okay, or actually if you have a group of students, or if you are a group of students, we can arrange a time and meet in the classroom and also discuss those questions. Okay, and also I'm thinking to to arrange maybe one or two problem solving session next week. Okay, and I mean the following 2 weeks before the final exam, and so that actually can practice some questions. Otherwise, I know that our speed, guys, we don't have much time. And 1st of May is holiday, 4th of May is holiday, 8th of May is holiday. We have a lot of holidays, and the SEA game is coming soon, right? And that's why we better sit now while we have time and study. So now in this session, we're going to talk about indefinite integrals and the substitution method. That is the method how to calculate more general integrals. Because in chapter 4.7, if you remember, when we actually studied about indefinite integrals, right? And we just actually did only simple ones. But now starting from today, starting from 5.5, after knowing or studying the definition of the definite integrals, we will focus on the techniques. At the same time, application and techniques, application and techniques, okay? So now we are going to use one method here that is called substitution method. And after that, we are going to use this immediately for substitution and area between curves, okay? And after that, we will focus on the application of definite integrals, all right? And once again, guys, you have to study everything from chapter 5 and chapter 6, okay? Just plus related race and optimization problems from chapter 4 to prepare well for your final exam. All right. Tisal, do you hear me well?
Yes, sir.
Very good. Thank you very much. If you hear me well, it's good. So now, if you remember in chapter 3, right, or we actually define the differential of f. How did they define the differential of f? The differential of f, let's say if you're given a function, y is equal to f of x, right? We define the differential of f as f prime of x times dx. Now, actually, it's time to start using this expression in our definite integrals, okay? So now look at this integral. Now let's start with indefinite integral. Okay, then we will apply this method to, what is it, calculate or to compute definite integrals. Now here we have indefinite integral, x cubed plus x to the power of 5 and 3x squared plus 1 dx, right? How do we calculate this integral? Let me just label this by I. How do we compute this integral? If you notice here, if I just label this part, let's say as, what is it? Not actually x to the power of 5, but this part, okay? Let's say by f. So that means that here we have f of x is equal to x cubed plus x, right? And now if you differentiate, this is what we have here. F prime of x is equal to 3 x squared plus 1. Actually, this part is exactly the derivative of this function, right? Here we have f prime. I can just rewrite this integral like this. So here we have integral, and let me just write, here we have, what is it? Here we have, let's say, f of some function, okay? In terms of this, let me just label this by u, okay? And here we have, what is it? F prime, right? F prime of x, or I can just write it like f, actually here we have g of x, right? And here we have g prime of x and dx. We have something like this. Okay, so in this case, how we are going to evaluate this? And this part, this actually, this f prime, this g prime and dx part, right? By using this differential, this g prime and x dx, I can write it as g dx, right? Because this g prime of x dx is just a differential of this d. So now I can just change this into this form. Then if I just actually substitute this thing, suppose that u is equal to g of x, then our function takes this form, that integral, and here we have f of u, and here we have du. Okay, so that's why actually this method is called substitution method. We are just substituting something for the expression in the function. Now using this method, then we know how to differentiate and integrate this part, right? Integral f of u du. That means that what function's derivative is f of u, right? So that means that we have to find the antiderivative of this function. Okay. Now we're going to give the theorem, but this is just an introduction part. Now, if I evaluate this, if I rewrite this function with in terms of u, then here we have u to the power of 5, right? And here we have du, where u is equal to, here u is equal to 3, u is equal to x cubed plus x, right? So now it's just a polynomial function. What function's derivative is u to the power of 5? That is 1 over 6 times u to the power of 6. And here we have constant, right? So now just to write your final answer, we have to write everything in terms of the original variable. What is our original variable? It is x. So this integral that I then is equal to 1 over 6 times u. What is our u? U is x cubed plus x to the power of 6. And here we have plus c. So that means that if you differentiate this function, we will get x cubed plus x to the power of 5 times 3x squared plus 1. Let's see another example. And after that, I think we have a theorem here. All right. Another example. Find the integral. That means a compute the indefinite integral. Using this method, okay. So this dx, how can I just write this integral in this form? Here we have integral square root of u, and here we have du. How can I do that? Okay, to do this, suppose that if I just label this 2x plus 1 by u, okay, and substitute this, now differentiate or find the differential of both sides. That is, what is du? Du is equal to d 2x plus 1, right? So what is the differential of 2x plus 1? That is 2 times dx. So you see here for dx, right? For dx, I can write dx is equal to 1 over 2 times du. So now if I substitute here, let's say our integral equals I. That's the first step. And the second step. So this I is equal to integral, right? By making the substitution. Now here we have square root of u. And what is dx? Instead of dx, I can write, and here we have 1 over 2 du, right? And it's just a constant number. By using the properties of the definite integral, I can just take this out. So here we have 1 over 2, and the integral here, what is square root of u? That is u to the power of 1 over 2. And here we have du, right? And actually, it's like x to the power of 1 over 2 and dx. So we know how to integrate this. That's equal to 1 over 2 and u to the power of 1 over 2 plus 1 over 1 over 2 plus 1 and plus c here, the constant. Or if you just simplify this further, and here we have 1 over 2, right? That is, what is it? 3 over 2. 2 goes up. So that's equal to 1 over 3, because 1 over 2 is divided by 3 over 2. That's equal to 1 over 3. Right? 1 over 2 actually times 3 over 2. I mean 2 over 3. So here we have times u to the power of half plus 1. That is 3 over 2 plus c. So dot, 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 then the given integral is equal to, what is it? 1 over 3. And here we have 2x plus 1, right? I can just write it as 2x plus 1 times square root of 2x plus 1 plus c. Or you can just write it as 2x plus 1 to the power of 3 over 2 plus c. Also, it's fine. Also, you can just write it as 1 over 3 and 2x plus 1 to the power of 3 over 2 plus c. Okay, that's actually the method that we're going to talk about here, how to evaluate this type of integrals. So the theorem says a substitution rule, if u is g of x, if u is equal to g of x is a differentiable function. That means, as you see here in the integral, we have g prime of x, right? So this actual g prime of x must make sense. Otherwise, I cannot use it here. That's why we are saying that u of g of x must be a differentiable function to use this method, and whose range is an interval I. And also in this range, right, f is continuous on I. So that means that, as you see here, we have f and its input value is g, right? So f should be defined on the values of this g. That is the range of g, right? Otherwise, we cannot integrate this. For a function to be integrable, right, at least partially, it must be continuous over the given interval. Then I can just write it as f of u du by introducing, what is it, this substitution. That is, u is equal to g of x here, right? U is equal to g of x. And as see here, why we are doing this is, see here, integral, and here we have f and g of x, right? I'm just actually replacing this g prime of x dx, because you see here, it is just the differential of g function, right? So we just writing here g and d, g of x. And what is our g function? Actually, if we substitute u for g function, then this integral becomes, here we have f of u and du. That's it. Find the integral. Now, guys, after just seeing this methods, let's focus on practicing more and more questions. Okay, as you practice maybe 8 questions, I hope that you will feel more comfortable, or you will be really comfortable with solving these type of questions. Okay, how do we integrate this? Again, let me just label this by I, second square root of 5t plus 1, right? And if you remember, what is the derivative of tangent function? Tangent function, and here we have tangent function that's equal to second square root of x, right? But here we do not have second function, but here we have second of 5t plus 1. So how can I change this into this form? Again, we are just introducing this new variable to substitute this 5t plus 1. Suppose that u is equal to 5t plus 1. Then what is the differential of u? Differential of u is equal to, as you see, if you differentiate this 5t plus 1 with respect to t, right, that is 5, and here we have dt. Or instead of this dt, right, dt, we can substitute, what is it, 1 over 5 times u du. That's the first part. So the second part, computation part, so that is integral. So here we have second squared of, what is 5t plus 1? It is u. And how about dt? dt is 1 over 5 du. Let me just write 1 over 5 here, 1 over 5, and here we have du. It's like second square root of x and dx. Now we can ask ourselves, what function's derivative is second square root of u? It is just tangent of u, right? So that's equal to 1 over 5, and here we have tangent of u plus c. And dot, dot, dot. Now we need to write our final answer of the result in terms of the original variable, that is in t, right? So that's equal to 1 over 5, and here we have tangent, and here we have 5t plus 1 plus c. So if you differentiate this 1 over 5 tangent of 5t plus 1 plus c, you get second square root of 5t plus 1. Another example, find the integral solution. Okay, once again, guys, as you know, we have already started talking, studying about integrals, different integrals. From now on, all the topics, except for just partial derivatives, everything's about integral. That's why to be really good at integrals, you need to practice as many questions as possible to actually, how to say, feel comfortable. want to just feel, you can say to yourself that, oh, now I can solve every question. And that means that you have reached a good certain, or let's say good level of understanding, or let's say the quality of learning. And that's what, to reach that level, actually you need to practice a few questions, not a few, actually a lot, maybe at least 50 or 100 questions from this chapter. And how about the next one? Now, immediately I can introduce this our variable, this new variable u. Let's say that's equal to 5 theta minus 3, right? And what is the differential of u? That is 5 times d theta, right? So that means that instead of d theta, we can write 1 over 5 du. So now if I rewrite our integral here, this integral cosine, what is 5 theta minus 3? That is u. And for d theta, I can write 1 over 5. So here we have 1 over 5 and du. Okay. Du. So this thing is equal to this thing is equal to 1 over 5 times what function's derivative is cosine of u? It is sine, right? It is sine of u. And here we have plus c. So dot, 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 then the given integral, let's say this I again. This I is equal to 1 over 5 times sine of u. What is u? U is 5 theta minus 3. And always we need to add a constant, right? That's the difference between definite integral and indefinite integral. Indefinite integral, the result of indefinite integral, right? It is a function plus constant, right? Always we need to add constant. And how about definite integral? Definite integral of certain function from a to b, it is a number, right? It's just a real number. Another example, find the integral. Integral, here we have integral sine x squared times sine of x cubed. Now, immediately as you practice 4 or 5 questions, the idea comes so quickly. Why? Because I really believe in this thing, in learning math, K-E-I, right? What is K? K stands for knowledge, E stands for experience, and I stands for insight. Insight. Okay, and this one is experience. Experience. And how about K? K stands for knowledge. Okay. Yeah, but now by listening, watching videos, reading a book, you get knowledge, right? From somebody or from the book, from the, I don't know, YouTube. And now actually to consolidate this knowledge, right? So that your brain, your spirit, your body, everything, except to do this one, you need some experience. And how do you gain experience? By practicing questions, right? And similar questions. And together, this knowledge and experience somehow, I don't know how is it, but somehow it produces some kind of insight. When you look at the question, you say, I know that, right? The idea comes so quickly. And you can feel that. You have some kind of feeling that, oh, I know that, I can do that, right? And that's why you need to do really experience and knowledge is important in learning math, maybe in learning everything, but particularly in math. So now when you look at this question, immediately, the derivative of x cubed, right? It is x squared. So now if I just consider this part, x squared and the dx, right? So I can just write it as what function differential is x squared dx? That is 1 over 3 and d and x cubed, right? And because the derivative of the differential of dx cubed is equal to 3x squared. And this 1 over 3 times 3 is just 1. And we have only x squared. And see here, I can replace this x squared dx by 1 over 3 times dx cubed. So the second step, let's say our integral is equal to I. So this I is equal to integral. And here we have sine of x cubed, right? So this x squared and dx can be replaced by 1 over 3. So 1 over 3 is a constant. Let me just write it here. And here we have dx cubed. And now here we have to introduce our variable, right? I'm going to substitute this u for x cubed. Let's say u is equal to x cubed. So here we have then 1 over 3 integral. So here we have sine of u and du. And we have already studied in chapter 4 how to integrate this function, right? That means what function's derivative is sine of u, that is minus cosine of u. So that is minus 1 over 3 and the cosine of u and plus c. So dot, 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 the given integral then is equal to minus 1 over 3. And here we have cosine of u. What is u? U is x cubed and plus c. Okay. So I think we have 8 examples, 6, 7, 8, 9, 10, 11, 12. Oh, okay, let's see as much as we can. All right, evaluate the integral. Here, let me use black. Okay. So this x times 4x plus 3, right? Again, if I just introduce this u as 4x plus 3, then what is the differential of u is equal to 4 times dx, right? So let's see here for this 4x plus 3, that is u, okay, right? So I can change dx, right, with 1 over 4 du. And now also we have x, right? From here, from the first expression, and also I can express x in terms of u. So what is x? X is equal to u minus 3 over 4. So now if I make all of these substitutions into our integral, let's say that's equal to I, that's our first step, and the second step, okay, green, the second step. So here we have this integral I is equal to integral I is equal to integral. What is x? X is u minus 3 over 4 times and square root of what is 4x plus 3? 4x plus 3 is equal to u, right? And here we have dx. What is dx? Dx is equal to 1 over 4. So that is, what is it? Du. And let me just 1 over 4 somewhere here. All right, let me just write here. And times here we have 1 over 4 du. Now, if I reorganize this expression, right, in a more beautiful way or standard form, this 1 over 4, 1 over 4, it's just a constant number. I can keep this outside this integral. So here we have 1 over 16 and integral. And here we have u minus 3 times square root of u, right? And what is square root of u? It is u to the power of 1 over 2. So here we have u and 1 plus 1 over 2, that is 3 over 2 minus, and here we have 3 times u to the power of 1 over 2. And here we have u. And these are just power functions, and we know how to differentiate, integrate power functions, right? So that's equal to 1 over 16. And what is u to the power of 3 over 2? That is u to the power of 3 over 2 plus 1 over 3 over 2 plus 1 minus 3 times u to the power of 1 over 2 plus 1 over 1 over 2 plus 1. And now here we need to add, what is it? Constant. So now if I just simplify this further, right? Here we have 2 and blah, blah, blah. So here we have, let me just everything in terms of the given variable. Okay, now. So dot, 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 and dot, dot, dot. Here we have, okay. So this I is equal to, the first one is, here we have 2 plus 3 is 5. 5 goes up, right? So here we have 5 over, sorry, this 2, right? Actually 2 goes up. So it is 8. 8 times 5, it is 40. So that is 1 over 40, right? Because 1 over 16. And what is it? It is times 1 over 5 over 2, right? So 2 goes up. Okay, it's correct, I think. So what is u? U is 4x plus 3. And to the power of 1.5 plus 1, that is 5 over 2 minus. And how about here? This one is 1 over 2 plus 1. That's equal to 3 over 2. 3 cancel each other. So here we have 2, right? 2 times 4x plus 3 to the power of 3 over 2. And here we have C. Okay. And also you need to write your answer like this. Some people, they try to, how to say, show more work and they make the things more and more complicated. No, that's it. Another example, evaluate the integral. Here we have integral in the numerator z times dz, denominator cube root of z squared plus 1. Okay, now immediately when you look at this z dz, right, z dz, so this z dz, we can write it as, what is it, 1 over 2 d, and here we have z squared plus 1, right? Because if you differentiate z squared plus 1, that's equal to 2z, just 2z. And 2 to cancel each other, we have z dz. Okay, so now I'm going to replace actually this z dz by 1 over 2 dz squared. And after that, and also we're going to introduce this new variable that is for substitution, right? Let's say u is equal to z squared plus 1. Okay. Now in the second step, and that integral, let's say this I, so this I is equal to integral. And what is z dz? That's equal to 1 over 2 and d z squared plus 1. What is z squared plus 1? That is u over, in the denominator, here we have u to the power of, it is cube root of u, right? That's equal to u to the power of 1 over 3. Or if I just rewrite this, 1 over 2 is a constant, so you can just keep this outside this integral. So here we have 1 over 2 integral and u to the power of minus 1 over 3. And here we have du. Again, it's just a power function. You know how to integrate this, right? That's equal to 1 over 2 u to the power of minus 1 over 3 plus 1 over minus 1 over 3 plus 1. So that's equal to minus 1 over 3 plus 1, that's equal to 2 over 3, right? 2 to cancels each other. So here we have 3 and u to the power of and 2 over 3 plus c. So then dot dot dot, the given integral is equal to 3 times u. What is u? U is z squared plus 1 to the power of 2 over 3 and plus c. All right. Example 8. Integrals of integrals of sine squared of x and cosine squared of x. Now you will see that integrating powers of trigonometric functions. Like here we have the simple one, sine squared and cosine squared of x. In general, it is not that easy. Not easy means it's not so difficult, but it's not short. In 1 or 2 steps, you cannot get the answer. And that's why we will talk about the general method to integrate the powers of sine functions or cosine functions, okay, or involving the sine and cosine in chapter 7, okay, in integration techniques, okay, and how to integrate, for example, sine cube or sine to the power of 4 or 5, or in general, sine to the power of m, okay. So we don't have just one answer, we have kind of formula, okay, only we can reduce the power. But here, by just using the substitution method, we are going to find a way or evaluate the integrals of these two functions. Let's start with the first part, solution for sine function. Okay, so that let's say this I, the integral 1, that's equal to, okay, integral, and here we have sine squared of x, and here we have dx. How to integrate this? And directly we cannot do that. To do this one, I have to reduce the power of this sine. And because I know how to integrate sine function, right? It is just equal to cosine function, but sine squared, we cannot. So to do this one, we are going to use this identity. We know that actually sine squared of x is equal to 1 minus cosine of 2x over 2, right? So now if I just substitute here, what we have here, so that's equal to integral. So 1 over 2, I can just keep this outside this integral. Here we have 1 minus cosine of 2x and dx. And now if you evaluate this, here we have 1 over 2. And what is the antiderivative of 1? That is x minus what function's derivative is cosine of 2x? That is 1 over 2 sine of 2x, right? And here we have plus c. So that is the, what is it? The integral of this cosine function. And how about I2? And how about this, the second one, integral, and here we have cosine square root of x dx. Again, we are just going to use that identity. What is that identity? Cosine of 2x is equal to, what is it? 2 times cosine square root of x minus 1, right? Or that's equal to 1 minus 2 cosine square root of x. Sorry, it must be sine. 2 times sine square root of x, right? So using that identity, I can express cosine square root of x in terms of cosine. As you see here, what have we done here is reducing the power, right? It was 2. Now the powers of cosine function is 1, or trigonometric function, it is 1. So here cosine of x squared, right? We can write here cosine square root of x cosine square root of x is equal to, what is it? 1 plus cosine of 2x divided by 2. Okay, now if you substitute here, that's why we call the substitution method. Integral, again, 1 over 2 is here, right? Here we have 1 plus cosine of 2x dx. So that's equal to 1 over 2. Now we can ask ourselves, what function's derivative is 1? It is x. Plus, what function's derivative is cosine function? It is sine function, right? So that is sine function 1 over 2 sine of 2x and plus c. It is plus c. Now we have some exercises, okay, from 5.5, 53, 50, what is it, 53? This must be 54 and 59 and 60. Maybe I will show them in our separate videos, okay? I'm going to choose some questions from each exercises and make some other videos, okay? So we have time now. We can maybe solve 2 questions here. So we have 10 minutes, okay. So now evaluate the integral from exercise 5.5. So 2r minus 1 and cosine of 3 times 2r minus 1 and plus 6 and 2r minus 1 squared and blah, blah, blah. Okay. So how are we going to evaluate this? Actually, we are going to use this substitution method twice here. And number one, the first, okay, suppose that let me introduce this thing. U is equal to 2r minus 1. So 2r minus 1, then here we have du is equal to 2 times dr, okay? Or dr is equal to 1 over 2 du. Now, if I just make this substitution, what we have here, integral will be equal to integral 2r minus 1, that's equal to u, and cosine of square root of 3 times 2r minus 1, it is u squared plus 6. Okay, over, and here we have square root of 3 times u squared plus 6. And how about dr? dr is equal to du over 2. So here we have du, and here we have 1 over 2. Okay. So now I'm going to make another substitution here, because how can I evaluate this? We cannot. So this u and du, right? See here, if I introduce another one, let's say w is equal to the second one. Let me use a different color here. Okay. And the second one, suppose that w is equal to 3u squared plus 6. Then what is dw? What is the differential of dw? That's equal to 6u and du, right? Or this, instead of this u du, as see here u du, I can write dw 6. So now substituting this one. So here we have 1 over 2 integral. And so here we have cosine and square root of, what is it? It is u, right? Cosine of square root of, what is it? It is w over, and here we have square root of w. And how about du? And u du is equal to dw over 6. So here we have dw over 6. So I need to just write here 2 times 6. Okay. So once again, I need to change this because here we have, what is it? Square root of W, right? Square root of W, but here we have dW. How can I write dW here? So if I just introduce another one, okay, the third one is, what is it? Wx, let's say the Z, okay, Z is equal to square root of W. Or, okay, all right. So now, what is the derivative or differential of dz? I mean z, that is the differential of square root of w, right? And that's equal to, if you differentiate this, 1 over 2 times 1 over square root of w, and here we have dw, right? And see here, instead of this dw over square root of w, I can write 2 times dz, okay? Then our integral becomes 1 over, and here we have, let's say this 2 times 6 times, and here we have 2, right? So 2 goes here, okay. Because this 2, right, it just goes to the left because dw over square root of w is equal to 2 times dz. So here we have 2 and integral. So here we have cosine and square root of w, it is z. And d, and what is dw over square root of w? That's equal to dz. Okay, so now if I evaluate this, it is equal to 1 over 6 times cosine of z. What function derivative is cosine of z? It is sine of z plus c. Or that's equal to 1 over 6 sine of, what is z? Z is equal to square root of w. Or that's equal to, again, plus c. Again, plus c. Or that's equal to 1 over 6, and here we have sine of square root of w. What is w? W is equal to square root of 3u squared plus 6 plus c, right? And now, how about u? U is equal to 2r minus 1. So now we can just write our final answer here. It is dot and dot and dot. The given integral is equal to 1 over 6. And here we have sine square root of 3 times u. What is u? It is 2r minus 1. And here we have squared plus 6 and plus c. Okay, guys, let's do one more example, then we'll have break. So now you got the idea. Okay, we can do this a little bit faster, I think. Okay, here we have sine of square root of theta, and here we have square root of theta, right? Cosine. So how can I rewrite this integral in a bit more simpler way? And suppose that first, let me just introduce this one. U is equal to square root of theta. And now we have just done this, right? What is du? Du is equal to 1 over 2 times square root of theta times, and here we have d theta, right? So now our this integral, I can just rewrite this as integral. So here we have sine of square root of theta over, and here we have square root of theta times and cosine of cube, right? So that's equal to cosine of square root of theta, and here we have square root of cosine of square root of theta. Okay, let me also write our d theta here. All right. Now, if I just make this substitution, what we have here? Here we have this I takes this form integral, and here we have sine of, what is this, d theta over square root of theta. I can write 2 times du, right? So here we have 2 and sine of u and du over, and here we have cosine of u square root of cosine of u. Okay. So now, what is the sine of u? Du, so that's equal to 2 times, I think this cosine of u, cosine, square cosine of u, right? This cosine to the power 3 over 2. We can write it as cosine to the power of minus 3 over 2 u. And how about this sine of u du? That is the cosine of u, and with minus, right? Because the differential of cosine function is equal to minus sine of u du. Okay, so now we have, what is it? Just maybe you can introduce another variable, but you don't have to do that. But since actually we are talking about the substitution, let me do this one more time. and how to do this repeatedly. Okay, so now if I substitute this one, w is equal to cosine of u. At the time, our integral takes this form, integral minus 2 times integral. Here we have, what is it, w to the power of minus 3 over 2, and here we have dw. Now we are integrating this function with respect to w, which is equal to minus 2. So that is w to the power of minus 3 over 2 plus 1 over minus 3 over 2 plus 1 and plus c. Or if you just simplify this further, what we have here, just right here, equals, so minus 3 and plus 2, it is minus 1, right? So that is minus minus plus, and 2 goes up. So here we have 4. And the w to the power of minus 1 over 2 plus c. Or that's equal to 4. What is w? Cosine of u. That is square root of, actually, it must be in the denominator. So that is 1 over, 4 over square root of w. That is square root of cosine of u and plus c. And what is u? U is square root of theta, right? So we can just write the final answer then. So dot, 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 the given integral is equal to 4 over square root of cosine of square root of theta and plus c. Guys, that's all about substitution method. It's not hard, just you need to practice a few questions to improve your speed. Okay, so let's have break for like 15 minutes. At 3:05, we will have our second session.